Hello, Northern Europe, and welcome to the first of our series of Webinar Wednesdays. So every other week, we're going to release a new video like this one, where we're going to share with you some speed tips on helping you to improve your website. So first, we have Antoine, who will cover a few topics today.
So today we will cover a lot of speed optimization, and first we will start on how we measure speed at Google, and I will give you tips on what kind of tool you could use to measure speed and how to improve your website.
And last week, we hosted our first of our series of office hours, which will be on the off week of the webinars when webinars are not happening. So the second office hour is going to be next week on Wednesday, April 17th from 1 to 2 p.m. So if you have any questions regarding this webinar or any other challenges that come up during your speed optimization journey, join us for this call and you can ask Antoine anything about your challenges.
Okay, so let's get started, and we're gonna start this session with how to measure speed and the different tools.
Okay, let's start with the performance metrics. So when we talk about web performance, we have lots of metrics at our disposal, but there is a couple of metrics that I really like. So the first metric that I want to talk about is the first contentful paint. So basically, it gives that the information of there is something on the screen, the website is loading. So very important to have the first contentful paint to be sure that the user stays on your page. The second metric that I really like is a speed index. So speed index, long story short, measures the amount of time needed to get the first part of the screen fully loaded. Because when you think about it as a mobile user or even desktop user, you only care about the first part of the screen. Everything that is loaded below default can be loaded after. So the speed index helps us to focus on the first part of the screen. And then the other metric that I really like is the time to interactive. Basically, the time to interactive gives you the information of when all your JavaScript are actually loaded and when the user can use the website without any lag. And it's an important metric because without JavaScript, your site can be unusable. And we also care about how fast the JavaScript is executed. We don't only care about how fast visually your website is loaded. So that's why we also have this metric. And so a quick diagram to show you those different metrics. So the way that we measure the time to interactive is we start like kind of a chronometer. We start the timing when we load the page, and we stop the chronometer for the time to interactive when the main thread is idle for more than 5 seconds. So we can see that we have here like the big red bar, an important activity on the main thread, and then after like idle time, but not enough, it's not 5 seconds, we have like our main thread that is busy for a couple of seconds, and after we have 5 seconds idle time. So here we have our time to first interactive. And another way to measure that is to use the first input delay. It's something that you can check on the Chrome UX report that I will talk about later. But basically, it's the first input delays measures the delay between when the user interacts with your website and when the website responds. So if you are doing a lot of calculations on a main thread, and if the user tries to click or to scroll, there is like a high chance that your app will be super busy and not respond quick enough. So you will have a high first input delay. So it's important to keep a first input delay as low as possible. So to recap, so we have two goals. First goal is to visually render the site as soon as possible. And second goal is to be sure that our JavaScript that is responsible of our main application is executed as soon as possible. Okay, but it's important to first focus on the visual aspect and then focus on the JavaScript optimization when you work on web performance. So when we want to measure web performance metrics, we have two ways to do that. There is the lab data way and the field data way. So lab data, it's measurements that we do on a controlled environment. So for example, we will test your site on a specific server that is maybe on the data center, or even on your laptop that you use, but with a good internet connection when you code the website. So this is lab data way. And the other way to measure speed and web performance is through field data. And basically, it's getting performance metrics, but from your real user. And there is two ways to do that. Two ways that I will introduce to you: the Chrome UX report and Google Analytics or any other analytics provider. First, I want to talk about the lab data, and I want to talk about web page test. So web page test, it's a really interesting tool to measure speed, because we can test speed based on different scenarios. So here in this GIF, you can see that I'm measuring speed from Stockholm, Sweden, but you can pick any other locations. There are a lot of locations available. And after I want, for example, to generate Lighthouse report, so you can even get Lighthouse report with that. But you can set up like a 3G test or 4G test, or only repeat view or only first view, or all these kind of things. So it's it's a very interesting tool to measure speed in different scenarios. So when I test speed, thing I do is like I test the site in 4G, okay, and I run in first view only. I'm doing that because I want to reproduce the experience of a user coming for the first time on your website. So, for example, from Google Ads, and I run 3 tests. So as you can see here on top, there is test runs 3. So we run 3 tests to be sure that, for example, your backend cache is fully generated. Okay, and we take the median of those runs. So here we have our speed index, our first interactive, and everything. So speed index here, 3.4 seconds, which means that we had to wait 3.4 seconds to get the first part of the screen fully loaded. Another cool feature with web page test, it's the film strip view. So here with the film strip view, I can see the screenshots of the website load. So this gives me the information of what is the speed perception from a user point of view. And this also helps me to understand that, for example, this hero image is not loaded at 3 seconds. So it gives me more information in a visual way. Underneath, we have the waterfall. So it's something that I guess you are very familiar with, but very interesting too. With web page test, we have like all our metrics that I mentioned. So, for example, the first contentful paint, but we have also other metrics, and the first interactive there. So, web page test is a very interesting tool. If you want to measure the real user metric from your user, you can also use Google Analytics to do that. So there is an API, the user timing API in Google Analytics, but if you use another tool than Google Analytics, I'm sure that you also have this kind of API. And there is also this this plugin, this JavaScript module called perfume.js that helps you to send data to analytics, timing and everything. So I encourage you to have a look. It's very powerful. And with that, you can, for example, create your own metrics. So, for example, if you take a website like Twitter, they obviously care about like how fast visually the website is loaded, but they care even more on like how long does it take for the website to have like the tweet box ready. So how long does it take to let the user tweet something? So it's something that you can measure. So ideally, you should create your own metrics, your own performance metrics through these real user metric measurement. So when we talk about speed and when we consider what is fast, we usually say at Google that first contentful paint under 2 seconds, it's considered fast. A speed index under 3 seconds, it's fast, and time to interactive under 5 seconds. So you can use those as goals. Let's talk about performance budget. So when I work with clients on speed and web performance, the thing I see often, it's a huge focus on speed, on mobile speed for a couple of months, though the performance gets better. But after a couple of months or after like 1 year, the website is back to the same spot. Like the website is slow again. And why that? It's because everybody who's working on the website asks for a new feature. I know that they don't have time, so like they push new front end features, but without optimizing them, because like they have to release that anyway. So that's one of the problem. And the thing that could fix that, it's performance budgets. So what is a performance budget? So basically, it's a limit that you put for each kind of type of asset on your website based on different pages, for example. So an example of budget could be on your product page should contain less than 170 kilobytes of JavaScript on mobile. Each page should include less than 2 megabytes of images on desktop. Your page should be interactive in less than 5 seconds on a given phone, this kind of thing like that. Or you could even like set up performance budget based on the Lighthouse score. And to do so, there is like different tools. A tool that I want to present is Webpack. So I'm sure that a lot of you are using Webpack. And built in Webpack, there is a way to control and to configure Webpack to ask Webpack to emit errors or warning when the performance of your app is exceeding a certain threshold. So for example, you can put a max asset size or a max entry point size or these kind of things. And if you put a max on the Webpack configuration, you will get like this kind of error message, which are like super handy and useful to understand that okay, you went over the limit and you should like optimize your commit. So definitely an interesting tool. Otherwise, something that I recommend you if you use a CI tool is to use Lighthouse in CI. So it's something that you can use with Travis CI or Circle CI or any other CI tool that you may use, and you can set a minimum score to pass for each commit. So it's definitely something that you can set up, which will help you to keep the website fast. Let's talk about a way to optimize your website through the server response time. So in this presentation, I will talk in majority about like front-end optimization, but a couple of words about how to optimize the server response time. So in terms of speed, your server should respond under 200 milliseconds or less. And to measure that, the way I like to do it is through curl. So this is a curl command that will give you the time to first byte. Or you can use this node module that I created. So you install it, or npm install time to first byte ttfb-test. You type ttfb-test, you put a URL, and you will get 30 measurements, and you will get the average of those 30 measurements through curl. And with those measurements, you should be under 200 milliseconds. So if you are over 200 milliseconds, if you are more in the 600, 700 milliseconds, it's definitely something that you can improve. And to do so, there is some usual suspect. Though, first, try to look for uncached database requests. So definitely something that you can have a look at it. So thing that I see from time to time, it's websites making synchronous call to web services. So for example, they decode the IP address to get the location on the backend, or like they are calling a couple of API, but they are doing that on the backend. So something that you could do, it's something that your application is doing, is to move those calls to the front end. In this GIF, it's a good example. So when you go on GitHub and when you go on the dashboard, you can see that we have this spinner with loading activity, because I think that for them, getting the feed and with all the notification, it's something that is hard to cache or something like that. So what they decided to do, it's first they load the whole app, and only this part is loaded through Ajax. So when we analyze and when we check what is inside this request, we can see that we have HTML and everything. So if you are making complicated things on the back end that are taking a long time, maybe you can consider to move them on the front end side. Another recommendation is to pre-cache the slow routes with a service worker. I will not detail too much what is service worker here, but basically a service worker, it's a script, a proxy, who lives between your application and the internet. And in this service worker, you can interact with requests. You can, for example, store and cache requests, and these kind of things. And here, what you could do is like first register a service worker. So we register a service worker like this, and we can store and save requests with this kind of code. Obviously, it's not the exact code that you should use, but it's something that I will give you more information in another presentation. So my point here, to speed up the time to first byte with a service worker, it's to, when you land on the home page, let's say, and you know that you have slow routes, it's to fetch those slow routes in the background. So like the request will go through the service worker, go to your server, and go back. So it's the third step here. And when do you have the request back on your service worker, what I recommend you to do if you go for this technique is to store this response in the cache. And with the service worker, we use a cache called the Cache API, which is especially designed to store HTTP requests. You can have a look at those links, sw-preload-on.glitch.me, and you can check the opposite on sw-preload-off, which is the same website but same example, but without this technique. And so something that you could do, even if your routes are not super slow, it's to use the quick link library. So quick click is a library that has been developed by Adi Osmani at Google and the Chrome team, and it helps to load the subsequent pages faster by prefetching them during idle time. So, long story short, what this library will do is it will take the links that are visible on the viewport and preload them when your application is idle. And the interesting thing that you could do is to do that only when your service worker is registered. Then you run quick link and you save those links in the Cache API. So here, with all the service worker discussion, I didn't explain everything in detail. If you are not familiar with service worker, I will obviously give you more information in another talk. But remember that service worker is a proxy. You can cache requests. And with quick link, you can trigger a request and then cache them before the user click on links. And those links will be the links that are visible in the viewport. Okay, let's go back on the front-end side, and I want to talk here about the no slider approach. So my point is, do not use carousel on mobile. So why that? Because of the bad performance. So using a slider on mobile will kill your speed. From a marketing point of view, the first slide will get all the clicks. There is a movement that leads to distraction when the slider, the carousel is in autoplay. It moves when you read, looks like ads, and you need multiple images above the fold. We try to speed up the experience above the fold, and we need some JavaScript as well. So I have nothing against carousel on product pages. Obviously, I think that they are really useful. Against carousel on home page, on home pages, for example. And in my opinion, you should replace your carousel by static images. So if you check amazon.co.uk, or any Amazon website, actually, you go on the home page on desktop and you can see that they have a carousel on desktop, but they don't have one on mobile. And on mobile, they only have static images that are stacked like this. And from a user point of view, from a UX point of view, it makes more sense to do this. Because like if I'm super interested about the Amazon Football Club offer, I can just go and click there. If it was a carousel, this offer would be hidden. Or I would have to interact with the carousel to see that. So with this kind of integration, I can directly go to the offer that interests me. So if you use a carousel above the fold for the product page, I have nothing against that once again. but be sure that the first image is not loaded with JavaScript, and the first image of this carousel does not depend on JavaScript. Here an example. Here we are saying amazon.co.uk, and what they are doing is like the first image of the product is always visible, and when everything is loaded, they are loading more images in the background. So that's why, like, underneath this this product, we have loading images ... So super important, as we mentioned earlier. First thing, load the above the fold part of the screen as soon as possible. Okay. And second thing, be sure your JavaScript execution is fast. So here, well done on Amazon. Let's talk about CSS. So first thing that I recommend you when you want to optimize your CSS is to check the code coverage. Most of the time, we load way more CSS than we use. So it could be interesting to have a look on what is the percentage of used CSS on your site. So to do so, you can use the the coverage tab on Google Chrome. So to get that, you first have to it's Command Shift plus P on Mac and Control plus Shift plus P on Windows, and run an audit. If you click on a specific file, you can see in the file itself what is used, what is unused. So it can give you good hints on what to optimize. So here, for example, on this example, we can see that 96% of the CSS here is unused. Another thing that you should be careful about is the CSS, or I should say SAS or SCSS nesting. So sometimes, or like I should say often, I see crazy CSS selectors. So here I think it's still okay, but I can see sometimes like selectors that are 30 lines long, and those selectors are crazy because of SAS SCSS nesting. So if you use SAS, don't go more than 4 level deep. It's a common rule. It's called the inception rule, and you can have a look at why it shouldn't be more than 4 level deeps on that link. But long story short, if your selectors are super complicated, the browser will struggle more to calculate, so it will be slower. Another technique to speed up and to optimize CSS is to generate the critical CSS. So what is the critical CSS? So it's basically the CSS that is used only for the above the fold part. So here on that example of Amazon, so the critical CSS will be only the rule used for the above the fold. So only what you are seeing now on that screen. And to extract that, to get the critical CSS, there is a couple of ways. You can either do everything manually, something that I would not do, or you can use this critical node module. So it's a node module, you use it like in the example, you specify width and height, and it will give you the critical CSS in a separated file. And then once you have the critical CSS, the idea is to put it in between two style tags in your HTML document. And for everything else, for all your non-critical CSS, you should load them asynchronously with JavaScript. So you can use a function like load CSS that you can find on GitHub, like a short snippet. So load CSS on GitHub and you will find that. So I just want to show you that this technique is produce really good result, and that's why if you heard about AMP, accelerated mobile pages, with AMP you have to do that. You can't link external style sheets. It's a really cool technique, and as you can see here, it's the same page, one with the critical CSS and the other one without. And we can see that before we had our two CSS files, so request, the second request and the third request, like the green bars are the CSS, and on the optimized version, now our CSS is actually in the blue request, in the first request, because we inlined the critical CSS. So when we are done with this blue bar, when we are done with the first request with the HTML document, we already have the style we need to show something to the user. So that's why it's super fast. And we asynchronously load our other CSS file after like our page is loaded. So here are the two green requests, and we are not blocking the rendering with that. So I just want to mention that it seems to be a really cool technique, and it is, but it's very hard to deploy on a real site. I mean, because like you have different templates and everything and different viewports, you will have to, if you want to use that, you will have to generate a different critical CSS to maintain them and everything. So my point of view here, it's do the critical CSS only on landing pages. If you have a specific landing page and you know that you will receive like a lot of mobile traffic, definitely do that. Or if you can do that, but maybe only on one type of page. But it will be quite hard to do that across different pages. You can try, but so if it's too complicated, it's completely normal. It's a really hard technique. Let's now talk about the JavaScript optimization. So first thing first, and I think it will sound very basic for you, but you should avoid render blocking scripts. So render blocking scripts are the script that you put in the head of your page that are slowing down the visual rendering of your page. So the classic behavior of a script tag, it's first when the browser parse your HTML page, and when the browser encounter a script, everything stops, the HTML parsing stops. The script is downloaded, so it's what we have in purple. The script is executed, it's what we have in red, and we continue to parse the HTML. But when we download and execute, we don't continue to parse the HTML, so we are stuck. So if you put JavaScript file on top of your page like this, without doing any optimization, you are blocking the rendering and you are slowing down, and you have high risk to get really high speed index. So here, for example, we can see that those scripts are render blocking, and they shouldn't. So to optimize JavaScript loading, you can use async or defer. So async will put the HTML parsing only on during the script execution. Defer will execute the script after the HTML is fully parsed. And my recommendation here is to use defer if the order of your script matter. So, for example, let's go back a couple of years ago, and let's say you are using jQuery. You load jQuery, and after that you are loading a jQuery plugin for a super cool carousel, let's say. And after that you have an app.js, and in this app.js you are triggering, executing, initializing the jQuery carousel. So then in your app.js you need to have jQuery, and you need to have your carousel defined before you run that code. So in your code you put first jQuery, then the carousel, then app.js, and everything works. If you decide to optimize that, and if you decide to put async on those three scripts, the risk is that you will maybe get app.js executed before jQuery, all these kind of things. So async will not keep the order of the scripts. Defer will. So most of the time, I recommend you to use defer if the loading of the scripts matter. If the script doesn't have like any, it doesn't matter in terms of the order. If it's a marketing tags or something, you can use async. Another catch that I see often, it's A/B testing script loaded all the time, everywhere on sites. And first, it's important for you to understand why an A/B testing script can be problematic. So an A/B testing script had the ability to inject code in your page and to overwrite what you coded on your page to make some modification, version A versus version B. So in A/B testing script, you will have a JavaScript that will be executed on the page plus CSS and everything. And A/B testing scripts are most of the time blocking the rendering of your page. Why that? Because if they are not blocking the rendering, the risk is to have your original page loaded, then the A/B testing script is loaded and executed, and then the new code from the A/B testing script will repaint and do crazy modification on your page. And then from a user point of view, you will have kind of a flash. First the original page, and then the A/B testing script executing everything and changing stuff on your page. And this can skew your test. So that's why A/B testing scripts are blocking. And the way to optimize them is to first do not load A/B testing script on mobile, for example, if you are not doing running test on mobile. That's pretty basic, but it's not something that I see often as an optimization. As well, do not load your A/B testing script when you are not running tests. So pretty basic, but be sure it's an optimization that you deployed. Okay, now let's talk about the JavaScript optimization in general. And obviously, you should keep JavaScript payloads at minimum. So first, as I mentioned for the CSS already, check the CSS, the JavaScript, sorry, coverage on your pages. So if you see, for example, that 90% of your CSS is unused on the page, there is maybe some optimization that you can roll out. So to reduce JavaScript payload, first you should analyze your bundle and to find opportunities. So if you use Webpack, and I'm sure like a lot of you are using Webpack, there is this cool package or cool module called Webpack Bundle Analyzer, which will create an interactive map of all your dependencies. And you will be able to, for example, to quickly flag a specific library, which is like loading like a lot of non-super useful things. Or for example, if you use Lodash and you are loading all the Lodash functions instead of like only the functions that you use, or these kind of things. Another optimization is to be sure that your app leverages trace checking. So first, what is trace checking? Trace checking is basically an automated way to remove dead code from your bundle. So we all use libraries when we code, and as I mentioned, for example, for Lodash, maybe if you use Lodash, you maybe do not use all the Lodash functions, maybe only a couple of them, 10, 20 max. But the thing that you don't want is to ask your users to download all the Lodash functions. So here, trace checking can help you to remove all the unused function from Lodash in your bundle. So to use trace checking, you should use a bundler, so either Webpack Rollup or Parcel, and you have to use the ES6 syntax for import export, and you should not use the common JS way to load modules. Otherwise, the trace checking will not work. Here, important catch, it's if you use Babel, there is a high chance that your ES6 module syntax for import export is transpiled to CommonJS. So if you do that, trace checking will not work because Webpack will not find any ES6 declaration to work with. So be sure that you deactivate that to use trace checking. So here, an example in Babel, I put module at false. Okay, now I think it's a killer feature of bundlers and the biggest weapon that I have for you in this presentation to speed up your website is to use code splitting to reduce your JavaScript payload. So this unfortunately works only with bundlers, so that's why I definitely encourage you to move and to use a bundler today. But code splitting allows you to load a module dynamically, or piece of code dynamically in your app, and with that you can save big. So, quick example. Let's say we are on a page, and this page contains a form. To validate user inputs, I use a library called Validator. And Validator has really handy methods like is email, for example, to check if a given string is an email. And here with code splitting, what I do is first I check if our page contains a form. So query selector form. If it's a case, what I will do is to import my library, but only if I'm on the page that contains a form. So then, going back, this will create different chunks in our bundle. The chunks with this will be separated and only loaded when we are on form. And all this logic is handled by your bundler like Webpack. Something else you can do, and here it's more if you use front-end framework like React or Angular, Vue.js. Here it's a Vue.js example. You can lazy load routes. So here, as you can see in my application, I have two routes. I have the home page, which had the dashboard alias, and the component is dashboard. And my other route is team, so /team. And what I'm doing here is I'm only loading the code responsible of /team when the user is going there, thanks to component. So this is Vue.js related, but thanks to import, Webpack chuck name, the comment is important, and team. So this will generate a separated JavaScript file at build time. Let's talk about images. Images are a huge part of our websites, and it's important to optimize them. To optimize them, first thing is to load images at the correct size. So to do so, I recommend you to serve multiple image sizes. So for most sites, serving 3 to 5 different sizes of an image, it's interesting. So for example, here, if you check Instagram, we have like 3 sizes when we check one image, and 5 when we check all the image together. To generate like different images, you can do that through Node with like the Sharp Node package that I use. It's quite handy to do that if you want to resize images. And there is another one called GIMP. So once you have your images, you can use a source set attribute for your image. So in your image tag, add the source set attribute, and then you can add different URLs that will be downloaded based on the size of the viewport. So pure front end, pure HTML, and works great. Second optimization that I have for you is to lazy load your images. So lazy loading allows you to trigger the image download before the user needs it, and to only load images that the user will actually use. So as you can see here on this GIF, when I'm scrolling, triggering more and more images to display. So to do so, I use a library called Lazy Sizes. It's a very popular library for lazy loading on GitHub. And the way it works, it's the markup. It's very similar to what we saw just earlier with the source set. The only thing is like we use data dash before src or before sizes. And here I added the class lazy load. So there's like obviously tons of different options. But obviously, I encourage you to have a look at the documentation. This library works great. I think it's even optimized for Internet Explorer 6 or 7. So if you use or if you have to support this, first of all, I'm sorry for you, but please know that you can use lazy sizes to do that. Okay, and another thing that I don't see often, but I think worth to be mentioned here, it's to not use GIFs on a site, but use video instead. So GIFs are crazy big. So the other day I analyzed the website of a client and I found this GIF, and this GIF was like 5 megabyte. So it was insane. As you can see, like the bar in web page test is like very big compared to the other. So what I recommend is to convert this GIF to video. To do that, I use FFmpeg, and you can easily like generate a video out of it. And then use a video tag with those attributes: autoplay, loop, mute, and plays inline. And this will mimic a GIF, and so it will be looped and everything. And the really cool thing is like here, normally like this is animated, but on the left we have the GIF, the original one with a 5 megabyte, and the video is only 400 kilobyte. So it's huge. So if do not use GIF, use videos. Okay, obviously another recommendation is to compress your images. So there is 2 ways to compress images, 2 kind of algorithm to compress images. See, the lossless algorithm, which will not harm the quality of the image, and the lossy algorithms that will change the quality. So at minimum, you should use lossless compression, and most of you should use lossy compressions. So as you can see, lossy compression between 0% to 100%. 1% it's basically no compression. So we can see that if we compare 100 to 80 or 100 to 60, the difference from here is like very, very minor. You should like really zoom to see the differences. So this should work for most of you. Indeed, if you set the quality to 80 or 85%, you should be able to reduce the file size by 30 or 40%. So, and it's really, really hard to tell the difference between a 100% quality and 80 or to 85. So to generate and to compress images in bulk, you can use ImageMin for your assets. I mean, when I'm talking about like optimizing those images that are part of your front end, not like maybe images that users are uploading on the site. There is like other optimization that you can do for that kind of images. But you can use that with Webpack in the command line with Node, Gulp Grunt, and everything. And you can, with ImageMin, for example, target a specific folder and optimize all images that are in this folder automatically. And here at a quick example, I took this image from a client site, and the original image was 155 kilobytes. I compressed it with the most JPEG tool at 75% quality, and the image was 87% smaller. Okay, so 20 kilobyte versus 155 kilobyte. There is a cool tool to test different algorithms and different settings. It's squish.app. So squish.app, I put the link at the bottom right. It's a website, or I should say an app, where you can upload an image and optimize it. And it could be very interesting for you to, for example, show to marketing teams how you can optimize images without actually a huge quality loss. Let's talk about the fonts and how to optimize them. So first thing, you should use WOV2 format with your fonts. So WOV2 is a modern format for fonts that is lighter than WOV and lighter than OTF or TTF. And using WOV2 doesn't mean that that some browser will not see your custom font. So actually, the browser will pick the first font format that he understands. So here, if my browser is compatible with WOV2, it will take WOV2. If it's not compatible with WOV2, it will continue and try WOV and so on. So very important to generate a WOV2 format. If you don't have this format, I ask you to go on that site that is on the bottom right of this slide, fontsquirrel.com/tools/webfonts-generator. And there you put your font, you click optimize or whatever they put in the call to action, and you will get the WOV2 formats. Okay. You should, with your font, avoid the FOIT, flash of invisible text. So this is what the flash of invisible text is. Your page is loaded, but the content is not. So the HTML is here, everything, but your font is not loaded. So you start to navigate and everything, but you can't read the text. So, and after a couple of seconds, the text flashes. So not ideal. Let's see how we can improve that. To improve that, you can use a link rel preload tag. So put link rel preload as font, href the URL of your font, and basically the link rel preload will tell to the browser, you know what, I will use this resource soon. We will use that resource in the page. So trust me, you can start loading it. That's basically what link preload is doing. So you should have that. And after that, you also should use a font display CSS property. So font display is a new CSS property to control the font loading. So with font display swap, so swap is the value that I recommend for this property, but there's other values, so you can have a look online. But swap basically will show a default font and then the custom font. So it's easy and nifty technique here to speed up your fonts. So here different font display properties. You can block, you can fall back, and optionals and different things. But swap is usually what you should go for. And then you should get something like this, where you have a foot, a flash of unstyled text. So text is unstyled and swap and line styled. So it's way better than what we have with the Flash of invisible text. That's it for the font. It's definitely not something crazy optimization there, but optimization that will help to perform very fast loading time. Thank you for joining this session and watching this video. Just want to mention that all the tips that I presented in this presentation are also available on this website that I created, speedchecklist.com, and you will also find other optimization there. If you have any question, I will be more than happy to help you. So feel free to send an email to ne-speedrace@google.com or directly send me a message on Twitter at Antoine BR. Thank you and have a good day.